Hey, this is John Howard from Google, and software engineer at Google, working on Istio. Today we're going to be talking a bit about the Kubernetes Gateway APIs. If you have no idea what that is, don't worry. We're going to kind of go from the start to where we are today. So let me give a bit of an overview of what we're going to be discussing. So, like I mentioned, first we're going to talk about kind of what is the API and why we need a new API. And if you were at IstioCon last year, I gave the same talk. So this year I'll probably be a bit more brief, but if you have some more questions, feel free to ask them in the chat or go look at the talk from last year where I go into the intro a bit more in depth. But what I want to focus on mostly is what's changed in the past year. This is a pretty rapidly developing area on the project. So there's a lot of great new stuff that I'm going to go over. You may find that each individual thing may not seem super exciting, but I think at the end, I'll kind of show them all together. And hopefully it's a pretty satisfying closure when we see like how all these pieces that we've been working on come together and kind of the overall experience of using the new API. Then at the end, I'll also talk about kind of what our future plans are for the API. So with that said, let's kind of get started talking about what is this new API and why we need it. So before we talk about the new stuff, I think it's useful to look at where we're coming from. So if we go back in time, like the original networking ingress API was this ingress resource in the core Kubernetes. So this API has been around for almost the entire lifetime of Kubernetes, and it's served a pretty good purpose. Like it is very simple. You can see here that you can just look at this, even if you're not familiar with the API, kind of get a feel for what this does. And it's interoperable, right? Everyone implements this ingress API, whether it's Istio or Nginx or GKE or AWS. And so that's really powerful because you can use one consistent API wherever you go. That's kind of like the premise of Kubernetes in many ways. And with ingress, they bring that as well to load balancing. But there's a lot of problems with the API as well. So the API is extremely simple. And what that means is that most users that use it quickly need some sort of extensions, right? And this has kind of caused a divergence from the core API. And almost all ingress controllers end up having these customized extensions. So a lot of these are like annotations. Nginx uses this, for example, a lot. Other ones are doing full-on replacements of the API, which is what Istio did with the gateway and virtual service. And then there's some that also kind of augment them with their own APIs. So what this does is that we took this API that was like vendor neutral, interoperable. You could portably use it anywhere, but because it wasn't powerful enough, everyone had to go make their own custom extensions, and now it's no longer as interoperable, right? So there was kind of a trade-off on simplicity versus and interoperableness. So the new API that the Kubernetes community has proposed is called the Gateway API. And its kind of goal is to take all the learnings from both the ingress API and other ingress controllers and ingress providers like Istio and a bunch of others, and create a more modern API that meets both the goals of extensibility, so we don't have this like annotation proliferation and custom APIs, but also it's a consistent API across all the vendors. And so that's a very hard balance to achieve, but that's kind of the goal of the project. And so these APIs, there's kind of, instead of just one core API ingress, there's now a bunch of different ones. So there's like a gateway, which is very, very similar to an Istio gateway. Even the name is the exact same. And then there's different routes and different types of extensions that I'll get more into later. So kind of one of the core features of this as well is, rather than just having one resource that's like, there's not as much flexibility. You can't have a segmentation of permissions, that sort of thing. We're kind of splitting this up. And so you can have like infrastructure providers, cluster operators, and application developers in this example. They all have different roles. They all have access to different layers of the resource model. And so this allows a lot of powerful things. Some of the things that are exposed in Istio, for example. Like you could have your cluster operator creates a gateway in the system namespace that has access to privileged TLS certificates, that sort of thing, and then give application developers access to virtual services, so they can set up routes for their application without having to talk to the kind of cluster operator for every operation they want to make. So the exact same concepts apply here with the Gateway API. which I think is going to be a very powerful extension to Ingress. So I touched on this a bit, but I want to really focus on the ecosystem implications here. So one of the Istio API is pretty good, right? It's flexible, it's powerful, but because it's an Istio API, that means that the amount of integrations is based on the amount of projects that are willing to go add Istio-specific APIs. And they're probably getting similar concerns with adding Nginx-specific APIs, adding HA proxy ones. So it's quite a challenge to go add support for 25 different load balancing APIs, right? So some projects have, but other projects have not. So by having a standardized API, it really opens the door for this ecosystem of Kubernetes integrations. So we're talking about things like external DNS, Knative, cert manager, or just even getting like route configuration from off-the-shelf Helm charts of various applications. So these are kind of things that are a bit hit and miss right now with Istio. We're hoping with the new API, and we're already seeing this really, that these integrations are just like extremely abundant, and they'll work with Istio as well just by nature of us implementing the API. The other thing is that there's kind of very seamless migrations between different products. So because there's one API that's shared by many different vendors, changing between them should be fairly simple, and I'll talk a bit more in depth later on why that's so powerful. So I want to give a quick comparison of the actual like YAML files that you'd be using with the new API and with the Istio API. And one of the common trends we'll see is that they're quite similar. We've taken a lot of the learnings from Istio APIs, as well as other vendors' APIs, and brought them to the Kubernetes Gateway API. So the similarities are no accident, right? But in addition to taking the good stuff, we're also leaving out a lot of the bad stuff. So in a lot of the Istio APIs, there's some like ambiguities and things, kind of some quirks of the API that have come to light in the years that they've been in use. And so this is kind of an opportunity to have a clean slate and make a more robust set of APIs. So in this example, I'm showing a new Kubernetes gateway alongside an Istio gateway that are kind of provisioning the same thing. I'm saying I want a gateway, and it's for Istio. The host name, I have some host name and some port, and we provision things like that. You can see there's almost a one-to-one mapping of every field on the two APIs. Similarly, if we look at the route in Kubernetes and the Istio virtual service, once again, extremely similar. So we're kind of attaching the route to a gateway. We have a host name configuration, some matching logic, and then some destinations. And so you can see that while the kind of the shape of the API is a bit different, the general concepts that need to be expressed are quite similar. And we expect that we could have conversion logic to help migrate between the two. And I'll, again, talk more about that future path a bit later in the talk. The biggest change here really is that in the Kubernetes routes, they have a route per protocol. So there's like an HTTP route, a TLS route, a TCP route, whereas Istio has just the virtual service. But other than that, they are largely quite similar. Okay, so that's kind of the quick recap. I know that was pretty rapid fire. So once again, if you want more information, I have a bunch of links at the end of the talk. And you can also go look at my IstioCon talk from last year for a bit more in depth on the background on the API. But what I want to talk about now is kind of what's new. So yeah, I'll go over all these things. So the first thing is mesh support. So the API has been kind of driven largely from the perspective of ingress first, but not ingress only. And so Istio is one of the vendors that are kind of pursuing the mesh angle on it. And so we're kind of prototyping what that looks like in the new API. So mesh support is extremely important for Istio, of course, because we are a service mesh. And our kind of belief is that the same APIs that you use to configure your ingress gateways and egress gateways should also apply to the mesh, right? We don't want users to have to learn an ingress resource and then a mesh resource that have completely different logic and routing rules and other things, when a lot of the times the configuration you want is quite similar and the same, or even the same in some cases. So in the API, we're exploring adding mesh support. Currently, this looks something like this, where it's quite similar to virtual service. That's kind of the trend here, where we can say, I want to attach this route to the mesh. And otherwise, it's the equivalent of having a virtual service where you have the gateway equals mesh type. So some of the interesting things here is that we're really one of the first products that are exploring using the API for mesh. And so we expect that as more and more service meshes start to express interest in this use case, we'll kind of iterate on what this should look like. So while there's very defined specs and conformance tests for how an ingress provider should work with the API, there's not one for mesh. Like there's no spec for how mesh works with the route API. We've just kind of made our own thing. And so we're hoping that, as in the future, we'll start to expand that, have a more solid form of mesh that is hopefully interoperable with others. We're also looking to actually, regardless of the interoperability, make some improvements to the mesh to resolve some of the ambiguities, which unfortunately we don't have much details on that yet, but in the coming weeks, if you're interested, there should be a lot of interesting design docs shared in the working group meetings. The next thing that's really exciting in concept, but not in slides and pictures, is conformance testing. So the API has a set of conformance tests which are really, really important for the interoperability aspect. So these tests are very similar to like the Kubernetes conformance tests, which kind of assert that your implementation meets all the requirements of the API, and that kind of ensures that everyone's actually following the same spec and that it can be more portable. So these tests have recently been added to Istio, and as you can see, we have a bunch of green squares indicating we're passing. So I'm really excited that we actually have this common kind of language that we can speak with a bunch of other providers. And there's about 10 implementations these days, I think. And so like the set of implementations is kind of rapidly growing, and I think it's super, super powerful that we're all kind of using the same API now. So the other thing that's really exciting is the API. Currently, it's an alpha API in the Kubernetes SIG networking. And so there's still quite a lot of changes going on, but it's pretty rapidly approaching beta. It's expected to release the beta 1 release in the coming months. And we also plan for Istio support of the API to go beta when the API itself goes beta. So this is kind of a few implications. One, it means that this is the absolute best time to try out the API and give feedback, because it's late enough in the development that things have mostly stabilized. So you're not going to try something one day and then the next day it's totally changed. But it's also early enough that we still can make changes based on feedback. So the sooner you get your hands on the API, try it out for your use cases, give feedback on what works and what doesn't work and what should change and what's confusing, the better. And we love the feedback both from Istio's implementation perspective, but also from just the API itself. So if you have a chance, if you're a Istio user, check out the API. I have a link at the end of the slides, which is a link to the Istio docs on how to use them with Istio. You could also try them out with another implementation or both and kind of compare them. Anything is valuable. All right, so next, I think, is the coolest part of what we've been working on, which is about improving the management of gateways. So if you use Istio today and you want to deploy an ingress gateway, there's kind of a lot of steps, right? The first thing you do is you need to actually go install the gateway. And so this would be like creating an actual service and deployment. Typically, this would be done like through Helm or IstioCon, but there's a lot of methods to do this. But only after you create like the deployment do you then configure it with the gateway object. And so we kind of have these two parts, like there's the deployment itself and the configuration for it. And these need to be kept in sync. So you can see here, I have like the same label that's across all three of them. And I also have the same port that's exposed in both of them. And if you want to add a port or change a label, you need to make sure that like all three of them are updated. And often that means rerunning Helm install or an IstioCon install or something similar, just because you want to expose, say, some new port for your application. So for example, say I wanted to add MySQL, I may add it to my gateway, but later on I realized I forgot to actually add it to my service. And you may not realize that until after a few hours of debugging, what's going on? Why is my MySQL not working at all? And so, when you look at it on a single slide like this, it may seem pretty simple. Like, okay, like fine, just put the port in two places. It's not that hard. But in practice, we've seen that this actually causes a lot of friction for users. Like keeping everything in sync is one thing, but also just the fact that you need to go, recreate your service and deployment every time you make a change. We kind of have like this, it's quite redundant, right? Like the left side, the gateway object itself kind of says everything we need, right? We've already defined labels and ports. So why bother going to put things in the service as well and in the deployment and then having to keep them in sync? And this is really just scratching the surface of like desynchronization. There's all sorts of other issues we run into with this. Like what happens if my service has a port 80 with the target port of 8080 and my gateway has both port 80 and 8080 defined? Like what does that even mean? There's all sorts of these confusing edge cases that arise from this that kind of continually cause friction with users. So one of the things we want to do with the Gateway API is make the gateway object not just configure an Envoy deployment that we have to manage and expose with the service ourselves, but actually resemble that infrastructure as well. And so what we want is that a single gateway object, like shown here, will actually go and provision those Envoy pods and services and expose those. And so you just create a gateway, and under the hood, we have Istio creating this service deployment, possibly a horizontal pod autoscaler, pod disruption budget, all those other sorts of things that are needed to run a gateway. And it's all handled automatically by the system. So you no longer need to worry about maintaining all these objects, reinstalling things, running into problems like that. That's all managed for you. And so, for example, like here's what's happening under the hood on the right side. Like this would be automatically created and it's managed by the system. So that's no longer needs to be managed by the user. One of the other really cool things, I've mentioned this many times throughout this talk, but is interoperability. And so this concept of having a gateway object create these deployments and services is not an Istio thing, right? That's part of the API. And so if I say like, okay, I'm using Istio, it's great. I love that I can just create this simple YAML file now and I get a real gateway. But I actually want to check out Nginx, right? So the Gateway API has this concept of a class name, which is kind of saying who is this gateway for? Because there's a common API, we need kind of that distinguisher. So simply changing that to Nginx would be all it's needed to actually deploy a new Nginx gateway and start using that. And if I wanted, say, a GKE one, no problem. I just replace it with GKE. And what's especially powerful here is that, if a GKE gateway, that's like a cloud load balancer that's running out of the cluster. And Nginx one and Istio one are probably for deployments running in the cluster, right? And so they're actually quite different in how they're actually implemented, but the API that the user uses is exactly the same. And so I don't have to think if I'm switching from GKE to Istio, like, okay, like how do I go deploy an Istio gateway again so that I can configure it with the gateway? And same with Nginx, right? There's a common language now across all deployment mechanisms. And it's not just for configuring routing, but also for configuring deployment. So in the end, we end up with a state where it's like, okay, I can easily switch between my gateways, right? I can use my Istio gateway and I get MTLS, rich telemetry, WASM, all these cool features that Istio provides that people have been talking about all week at the conference. Or I can easily switch to GKE gateway and get the cool things that it provides, like Anycast global load balancing, managed TLS certificates, cloud armor policies. These are really cool, right? But I don't want to choose between one or the other. I may want both of them, right? And so you may think, I'll just put both of them in line. I'll have my traffic hit the GKE gateway first, and then the Istio gateway, and then finally hit my own application. And this is something that's really powerful because you can kind of combine the best of both worlds. And a lot of users actually do this in production, even today with the existing APIs. But the challenge is that it's very challenging to do it. So with existing APIs, it's extremely hard because both layers have completely different APIs. There's no shared language between them. And so configuring this is quite challenging, right? There's some documentation on how to do it. Last I checked, it was about 40 pages. It took me about 8 hours to go through it myself, and I have quite a bit of familiarity in this area. Even with the Gateway API, where we have this kind of shared language between the two, there's still a lot of stuff you need to manage, right? We need to have a routing configuration to hook these two gateways up together. We need to manage certificates in both of them. We need to add health check configuration, and on and on. There's more configurations not listed here. And even this only manages a single cluster deployment. Once we have multi-cluster deployment, the chart becomes way too big to even show on the slide. It's extremely complicated to set up. So, the idea of having these chained load balancers where we get both GKE and Istio, and this could be, I'm using GKE because I'm familiar with it and I work at Google, but this could be an AWS application load balancer or anything else. It could even, in theory, be, two in-cluster deployments like an Nginx gateway and an Istio gateway or something along those lines. So this is a very powerful concept. It's just really hard to actually do. And so kind of the future, I think, of the Gateway API plus Cloud Load Balancer integration, which is something that we're offering as part of Anthos Service Mesh on Google Cloud, is to kind of combine those two concepts into one gateway. So whereas before you'd kind of configure these things as two separate things, right? And then you have to manage everything for you. What we want to provide is a way that you can just say, I have a gateway and its type or its gateway class is Istio plus GKE. And instead of managing all these different layers, you can just manage one single gateway that kind of represents both of them under the hood. And I talked a bit about multi-cluster earlier and about how challenging that is. With this model, we can also automate all of that away. So a single gateway could actually represent entire multi-cluster deployment, where we could have clusters deployed across the world. We set up a global load balancer in GKE, which will send traffic to the nearest access point based on a client's geographical location. Send that to the appropriate cluster. Istio locality load balancing will ensure that it's kept in the cluster for optimal latency and cost and that sort of thing. And all of this can be expressed with just that one single gateway. One of the other things that's really powerful with this is that we talk a lot with Istio about canary deployments for applications. If I'm deploying a new version, first send 1% of traffic to it, and then 2%, 3%, kind of gradually roll it out so that it's a lot safer. But with gateways, which are arguably the most important application in the cluster because most, if not all, traffic is going through them, we don't really have a mechanism to do that, right? Because the gateway is we need Istio to do the canarying, and there's no Istio in front of the gateway in order to do it. We just have like clients connecting from their browser or whatever that don't have access to our canary weights that we want to set. But because now we have this cloud load balancer in front of Istio, we do have the capability of doing this traffic splitting and canarying of new upgrades. So while the user config may just look like one single gateway, under the hood, we have the possibility of spinning up multiple different versions of the Istio gateway. Because like I mentioned earlier, the gateway actually creates under the hood different deployments. So one gateway could create two different deployments of two different versions, and then also automatically configure the GKE gateway in front to do traffic splitting. So you may have seen Mitch Connors talk earlier in the week about upgrading automatically on Google Cloud. This kind of extends that concept to also apply to the gateway and do this really rich canary load balancing to safely do upgrades. And so, bringing all this together, we have this super simple gateway API. It's maybe 10 lines of YAML and very simple to understand, and the same as what you would use if you were just using plain Istio or Nginx or anything else. But this gives us like a huge list of features. We can get a global load balancer and IP. We get Istio gateways provisioned automatically in the required regions and clusters based on availability, latency, cost, that sort of thing. We can even, moving forward, do advanced things like, I set the example.com as the host name, and I had an IP automatically provisioned for this gateway. Well, we can also go and update the DNS record for example.com, assuming we own it, to now point to that IP. So that's one less step we need to do. Because we now have integration with the GK load balancer, we can generate a managed certificate for example.com. And so the certificate is fully managed by Google. There's no need to risk leaking private keys, anything like that. And the TLS is terminated at the edge. And all of this is done using the exact same API that would be used to configure any other load balancer implementation. And just reiterating things that the user does not have to do in this model is deploying and managing an ingress gateway deployment and service and kind of keeping that in sync, upgraded, all that sort of stuff. Manually configuring certs, DNS, and kind of managing their lifecycle, securing them, et cetera. Keeping all these resources in sync and, knowing what these resources are. Like there's tons of resources needed to pull this off, and they need to all be kept in sync. They need to be updated. You need to understand them. So with this new integration, like none of that is required, right? All you need to do is just create this simple gateway, and you get kind of all this for free. So I think this is like a super powerful, new feature that can kind of bring everything I talked about before, the automated gateway management, the interoperability, and provide a really compelling user experience where you get a ton of functionality, but without all the complexity. All right. Finally, I want to talk about where the API is going. So like I mentioned before, the API is moving to beta soon, but it's still in alpha, right? It's still fairly early, so all of our plans are a bit tentative, waiting to see where the direction of the API goes, how adoption is, all that sort of thing. But optimistically, certainly from my perspective, as I'm a big fan of the API, we're hoping that the gateway APIs kind of become the stable networking APIs for Istio. So you could imagine in the future, all of our docs where we go through traffic shifting, all those sorts of things, recommend using the new APIs as kind of the default mechanism in the future. But at the same time, like we're well aware that there's hundreds of thousands of virtual services, gateways, destination rules, all sorts of things that are out there in the wild in real live production clusters. And we have absolutely no intentions of removing these or deprecating these, even after the gateway APIs become stable, and even if or after they become kind of like the default APIs. So similar to how in Kubernetes they have the ingress API, which is kind of the older API. It may not be recommended in the future, but that API will not go away. And so we'll follow a similar path here, keep the old APIs, but still kind of recommend the newer ones for most use cases. And yes, I think that's it. So thank you everyone for listening. If you have any questions, feel free to check out these links. There's one for the actual API docs from the Kubernetes project, and as well the Istio docs for the API. So it's like how to use it with Istio. And for any other cases, you can join the Istio community, get access to our Google Docs, slides, Slack, everything like that. And yeah, if you have any questions, feel free to ask me now in the chat, I think, or on Slack later.